Henry Fagan, we called Henry Fagan and Partners. We are consulting structural and civil engineers. We concentrate mostly on structures, and we enjoy doing unusual and interesting works. That's what we really are strong on in our firm. The Viper is a little bit similar to the Boomslang project, which we finished a few years ago. In fact, that's because our client really liked the Boomslang that he asked us to do something similar at Emily in England. So it's basically a walkway up amongst a tree canopy, and it's a structure that rests on columns and then steel work that supports the whole little pedestrian bridge from where it leaves the ground at one point at the abutment at the one end, then goes for about 130 meters and joins up with the ground at the other end. At midpoint it's about 12 meters above the ground. There are a lot of very interesting and innovative details in the structure, and we think it's particularly elegant the way we've built the columns, for instance, the way we've built the tripods, the way those stanchions taper to such a very thin and delicate dimension just below the handrails, the way the shape has been curved, so it's one continuous curve that forms all the way around the bottom. Then maybe the way the columns are joined halfway. We haven't got flange plates that protrude beyond the column. All the flange plates are hidden inside, so you hardly notice the joint. And the connection between the base of the column and the top of the tripod was a particularly interesting detail. The tripods were manufactured and installed obviously in England, and the columns were made in South Africa, and we had to be very certain that that junction would work perfectly. And we devised a junction where the column could be orientated at any rotational angle, and the bolts would always still fit through by carefully designed slotted holes. So that was a very interesting detail as well. Yes, movement on slender structures like this, and as we had on the Boomslang, is always something that one has to look at very carefully. Fortunately, from the experience of the Boomslang, we knew exactly what to expect, and we could design it very accurately. With the software we have nowadays, you can actually take vibrations into account, and you can analyze exactly what you're going to get. So we thought that because we have bigger crowds maybe in England and maybe slightly more conservative than our people in South Africa, so we thought that we would limit the amount of movement to less than we had at the Boomslang, and we could design it accordingly. The structure itself is built slightly with slightly more stiffness, especially the columns, and we also introduced cables to stay the structure fixed to 2 anchor points. Firstly, it was obviously a bit of a challenge to work in England, whereas we positioned over here, so we flew over quite regularly. We had a very good survey done of the whole site, which gave us everything in precise 3D, sort of a cloud survey, so that made it easier to work from here. We used British contractors to put the project together, but we used South African contractors to build it over here. And then obviously some portions had to be built in England and some built over here, so we had to be extremely careful to make sure everything would fit together perfectly once it was assembled in England by the British contractors. We had South African contractors that built most of the structure. We found that was more economical for the client, or in spite of everything then having to be shipped in containers to England, but we had British contractors that did the erection over there. An interesting aspect was that we couldn't use concrete foundations as we might have thought would be the most economical. We actually had to use steel piles for basing the whole structure onto. Then each pile had a steel tripod which sort of rested on these 3 steel piles per column, and since these pile positions could not be predetermined very accurately, these tripods each had to be made exactly to fit with the positions that the piles had been installed. And then the tripods were then standing above the ground, and the top plate of the tripod had to be exactly the right position, such that when the column was fixed onto it, the column be in the right place and at the right level for fixing the bridge on top of that. That was one of the challenging aspects, and also a very interesting aspect of the whole project. I don't think any other material would have been applicable or practical for actually building a structure like this. It's really only steel. because the structure is so high up in the trees over there. Anything else like concrete would have been far too clumsy and intrusive. Steel is actually, well, I suppose one could have done it out of laminated timber, but steel is much stronger than timber, so if one wants something really elegant, especially if one looks at, say, our little balustrade section, those are extremely delicate, and no other material would have been practical to actually achieve something that was as delicate and appropriate to the site as steel. It's one of the most enjoyable aspects of working on projects like this together with Mark Thomas, is that the two of us are just so compatible when it comes to design of structures like this. We each contribute one little bit after the other until we both feel absolutely happy with the final product we've achieved. And it's really a wonderful process working together with Mark, and we both really enjoy doing that. And maybe we're also very proud of the way everyone worked together. The South Africans and our whole team in Britain, everyone worked together as one huge happy team to actually achieve something that everyone was extremely proud of in the end.